this video we're going to talk about the rescue configuration. You might be asking yourself, what do I mean by rescue configuration? Well, basically, it's a feature that the Junos system has for you to save a configuration that you deem good or worthy of saving, so you can use it later on in case you need it. Let's think of an example. Imagine that you did your initial configuration of the device. So the device now has a management interface, has routing, has users, firewall filters, etc., etc., etc. The configuration works perfectly and you're completely happy with it. So you could save that configuration as your rescue configuration, and then down the road, let's say in 3 months, some tool that you have changes the firewall filters, or even someone by mistake changes some part of the configuration, and now you're locked out of your device. If you have this rescue configuration with done right after you install the device that has connectivity and works properly, you could simply imagine that this is a remote site. You could simply call them and say, log me at the console and type this command. And it will that person wouldn't have to know about Juniper, wouldn't have to know about networking. It would be very easy to just roll back to that initial configuration that you had working and you could access remotely. So it's a very nice and it's a very good way of actually having that fail-safe system there that you can use in case of an emergency. That's why it's called rescue configuration. So it's quite simple to use, so let's see it. It's a few commands. The first thing we will have to do is, after we have the system in a known state, in a state that we know it's complete and it's reachable and it's manageable and we can log in, we should save that configuration. So we can do this with the rescue system configuration rescue command, request, sorry. So if we go request system configuration rescue, we can use the context sensitive help. Our options are either to delete it or to save it. So we can save it, we can delete it. So why would we delete a rescue configuration? Perhaps we want to update it. Imagine that the classical thing might be that when you did your initial deployment, that device was speaking, let's say, RIP. And now you migrated your routing to OSPF. So it wouldn't make any sense to still have the rescue configuration on RIP, because if you actually need to use it, speaking RIP when everyone else is speaking OSPF won't help you. So after you migrate to OSPF and you verify that configuration is stable, just as your old rescue was, you can replace it with a more up-to-date to make sure that in the end, if you need to load that configuration, it will load and it will enable you to reach that device and be able to do any configuration, even do some troubleshooting on why you failed to get connectivity or why the configuration failed previously. So let's do a couple of tests and see how easy and how useful this is. So I already saved the rescue configuration. So let's see what's on this device. This device only has a simple initial configuration that we did. So for our environment, this is good enough as an initial configuration. We have the host name, we have the root password, we have SSH and telnet enabled, and we have management interface. So good enough. That way we can actually reach it and we can actually do any configuration that we need. So let's test that it's actually still reachable. IP address is 254.242. So let's test that. So we can see that it's pingable and we could reach it by doing SSH or doing telnet. So let's do some changes and let's see how the rescue configuration works. So let's go into configuration mode. Let's say that someone by mistake, they want to delete something and by mistake they delete it or they disable, doesn't really matter, our management interface. So if we're working from a remote site and this is in a branch office, or if this is in a remote data center and it's in another city or another country, you will lose connectivity, and unless you have some other way of getting to the device, you wouldn't be able to do anything to configure it. So let's check it out. Let's delete, for example, the IP address on the M5. So now I do a show compare. Let's just delete a bunch of random stuff. Let's delete services. Let's delete telnet. So somebody went to town with the configuration. So we do show compare. We can actually now see that we don't have the IP address and we don't have the remote services enabled. So if we do commit, it will apply that configuration and I should see my ping stop working. Will happen as soon as the commit is complete, and as you can see, we see some pings failing. So now that the device is not reachable, and your monitoring system is sending you alarms, but you can't reach the device. So the option you could do is think of the remote side, or think if you have a console direct access, you could just use the rollback rescue command, or you could tell someone in the remote branch to do it, or someone in data center to do it. So let's go ahead and do it. So the command would be rollback rescue. Basically load the rescue configuration onto the candidate, and you can do a show compare and see what's the change. So as you can see, it has bring back the services and it bring back the interface. So now you can do a commit. So I know that it looks simple when we look at it in this example, but think about a device in production. Think about a device that has firewall filters, a device that has routing policies, a device. Typically routers tend to be quite dynamic in their configuration, especially if you look at how a configuration evolves over the months or even years. It can be quite hard to bring it back to a state where we knew it was completely stable, it was completely functional. So that's why that feature is there, and it's a good thing to have. Even if it's not in that particular scenario, you could do it before you do a big change, or before you do anything too sophisticated, or something that you're not quite sure what the end result is going to be. And we see that the pings start working, so we have restored the configuration. And that's pretty much how the rescue functionality works. So another interesting thing I want to touch on is understanding what's the proper way of shutting down a Juniper device. What do I mean by shutting down? Typically networking devices, you simply go and you remove power out of them and that's it. In the case of Juniper devices, remember that they're sitting on top, the Junos software is sitting on top of a FreeBSD server or OS. So it has a file system, and the file system has to be consistent, and the file system has to be unmounted properly. So if you just unplug a Juniper device, whenever you plug it back in, it's going to tell you that the file system wasn't unmounted cleanly, and it's going to actually check it, and you might have file system inconsistencies. And if the file system goes into a state where it's not repairable, you won't be able to start the Junos OS. So it's whenever you're going to shut down a device, it's good to actually do it the clean way. So a normal shutdown in Juniper is done with a command. So you will have to do request system halt. It's going to tell us if we want to halt the system, and it's going to basically make sure that most of the process under the Junos OS and under the FreeBSD OS are shut down cleanly. And after that's done, it's going to unmount the file system to make sure that you don't have any inconsistencies and you can actually remove power without any issues. And this is quite important because, remember, if you don't do it in this way, the file system might become corrupted and you might have issues. Normally, and you can actually see it, if you do it if you don't do it this way, just shut it down, remove power, and bring it back in, you'll see that now when the system is actually starting, it will bring you a message saying, I'm checking the file system was was not unmounted properly. I'm going to check for consistency and check if there are errors. So now the system is it's waiting for some process to stop, but we can actually see it, and it's going into an orderly shutdown. So we get some messages here that it's waiting a maximum of 60 seconds for some of the processes, and after that's done, you can actually see that those processes stopped, and now it's syncing the disk, which basically, like I said, is making sure the file system is intact, and it's going to unmount the system. And in the end, we'll get a message saying that this was a normal shutdown. It's safe for you to go ahead and power off this device or reboot it if you want. So it's an important thing to keep in mind when working basically with any Unix or Linux device, and especially with the Juniper devices. So as we can see, it gives us some information. It tells us that sync all disks, that all buffers have been synced, that the uptime of this device was 3 hours and 48 minutes, that it recorded this reboot as a normal reboot, and that the OS has been halted, that you can either shut it down or press any key to reboot. So, thank you.